Consider the graph of f of x and its inverse f prime of x. We see that the slope of the tangent line that passes through the point A, f inverse of A on the graph of f inverse of x is f inverse of f prime of inverse of A, that is P over Q. So recall the slope of f of x is equal to change in y divided by the change in x, right? This means the slope of f prime of x is equal to change in x divided by the change in y. So that you can see here in this term, what the slope of the curve, you talk about the slope of the curve, or the slope of the tangent line of the curve at the point A negative A. Q represent the change in y and P represent the change in x. And whereas here, again, it was just the original delta x divided by delta y. Okay. And so with that relationship, if f inverse of x is differentiable at A, then it must be the case that f inverse of A is equal to 1 divided by f prime of f inverse of A. Okay. The inverse function theorem. Let f of x be a function that is both invertible and differentiable. Let y equal f inverse of x be inverse of f of x for all x such that f prime of f inverse of x is not 0. Then dy dx of the function is equal to 1 divided by f prime of x, f prime of f inverse of x. So we're looking at a composite function here. Alternately, if we write y equal g of x, then is the inverse of f of x, then g prime of x equal to 1 divided by f prime of g of x. So let's take a look at the example. So you can see the theorem is a little hard to follow, but if you just look at the example, trying to do that, you will see the connection pretty clearly. Given f of x equal 1 over x plus 2, first we want to find the derivative of f inverse of x. But first we will take derivative of f inverse of x. Okay, so the instruction said by taking the derivative of f inverse of x. So first thing first, let's figure out what is f inverse of x in this case. So f of x equal y equal 1 divided by x plus 2. And to find f inverse of x, we exchange x and y. Then we will solve for y. So this is telling us that f prime of x, f inverse of x is equal 1 over x minus 2. So then d dx, or derivative of f inverse of x, is to take derivative of 1 over x minus 2, that is 1 over x squared. Now, here we want to find d dx of f inverse of x by applying the inverse theorem. The inverse theorem saying that d dx of f inverse of x is equal 1 divided by f prime of f inverse of x. Okay, so first of all, we need to find what is f prime of x. Well, f of x equal 1 over x plus 2. So f prime of x equal negative 1 over x plus 2 square. F inverse of x, we found it earlier, that is 1 over x minus 2. So then the composite function f prime of f inverse of x is negative 1 divided by 1 over x minus 2 plus 2 square. And that equals negative 1 over x square. And this equal to negative x square. So then d dx of f inverse of x equal 1 divided by f prime of f inverse of x equal 1 over negative x square. The answer is of the same. So whether we take the derivative of the inverse or we use the theorem, we get the same answer. Extend the power rule to rational exponent. The power rule may be extended to rational exponent if n is a positive integer. Then derivative of 1 over derivative of x to the exponent 1 over n, you can take 1 over n down and subtract 1, just like your other exponential rule. You can take the exponent down and subtract 1. So let's try this example. Given f of x equal the fifth root of 3x squared plus 5x plus 2 to the fourth, and we want to find f prime of x. First of all, I will try to write this in more simplification manner. So this is 3x squared plus 5x plus 2 to the exponent 4 fifths. Now, this is a composite function, so we need to use the chain rule to take the derivative. So f prime of x is equal to 4 over 5, 3x squared plus 5x plus 2. 4 over 5 minus 1, that is negative 1/5. Now that we already take the derivative of the outer function, we need to take derivative of the inner function. So 6x plus 5. And this simplify to 4 times 6x plus 5 divided by 5 times 3x squared plus 5x plus 2 to the 1/5. Even f of x equals sine inverse of x, find the derivative of this function. So recall that theta is equal to sine inverse of x. So then sine of theta is equal to x. Right? Then f of sine of theta, or f of x is equal to f of sine of theta is equal to theta in this case. Right? Then f prime of this function, we take derivative both sides. F prime of sine theta times cosine of theta is equal to 1. We take derivative with respect to theta. Then f is the outer function and sine of theta is the inner function. Right? So then f prime of sine theta is equal 1 divided by cosine theta. So we know that x equals to sine theta, right? So according to our right triangle, this is theta, this is x, is 1, then 1 minus x squared Square root is the adjacent sign, so this equal 1 divided by square root of 1 minus x squared. So f prime of x is equal 1 divided by root of 1 minus x squared. So here's the rule for derivative of inverse trigonometric function. I'm not going to ask you to prove any of this by yourself. On the test, this formula will be given to you. The derivative of inverse of trigonometric function. So let's use that first derivative to use the formula to find the derivative of the given. So g prime of x is equal to 2x times sine inverse of x plus x squared times 1 over 1 square root of 1 minus x squared h prime of x. So here we have a chain rule, right? So that's 1 divided by 1 minus 3x minus 1 square root times derivative of the inside, that is 3. So clean this up. 3 divided by square root of 1 minus 9x squared plus 6x plus 1. This is 3 divided by square root of negative 9x squared plus 6x.